This is an easy geometry question. The objective is to find out the area of the shaded region. This question appeared as a 3-mark question in 2016 CBSE Class 10 board examination. Let's quickly read the question. O is the center of a circle such that its diameter is equal to 13 centimeters and the measure of AC is equal to 12 centimeters. BC is joined. What we need to find out is the area of the shaded region. We need to take the value of pi to be equal to 3.14. Right? Before we start anything, let's understand what do we have to compute. We need to find out this area of the shaded region. AB is a diameter, which essentially means that this sector ACB ends up being a semicircle. So we need to find out the area of the semicircle. From that, we need to exclude the area of this triangle. So from the area of the semicircle, if we exclude the area of triangle ACB, we have the area of the shaded region. Now, if ACB is a semicircle, we know one very important property about semicircles, which is needed to solve this question. That angle in a semicircle is a right angle. So this angle ACB, the measure of angle ACB is equal to 90 degrees. That makes triangle ACB to be a right triangle. Do we know some measures of the sides of this triangle? We know the measure of the hypotenuse, which is a diameter which measures 13 units. We know the measure of AC, which measures 12 centimeters. So let's start by finding out the third side using Pythagoras theorem. AB square, which is the square of the hypotenuse, is equal to sum of the squares of the other two sides. Hypotenuse measures 13. So 13 square is equal to AC, which is a 12 square plus BC square. So BC square will essentially be equal to 13 square is a 169 minus 12 square is a 144. So BC square is equal to 25. Translating to the fact that BC is equal to 5 centimeters. So we got the measure of the third side of the triangle. So as I mentioned, how are we going to find out the area of the shaded region? We'll find out the area of the semicircle first. We know the radius of the semicircle. So let's find the area of the semicircle. From that, let's subtract the area of the right triangle ACB. Do we know measures of the sides of the right triangle? Yes. The measures of the sides are AB measures 13, AC measures 12 and BC measures 5. This part, area of a semicircle is pi r square by 2. So which is half into, let's take pi to be equal to 3.14 as said in the question, into r. Radius is equal to 13 by 2 because the diameter is 13. 13 by 2 the whole square. This is the area of the semicircle minus area of the right triangle is half into the product of the perpendicular sides. One of the perpendicular sides measures 5, the other measures 12. So this is half into 3.14 into 13 square is a 169 divided by 4 minus the 2 and 12 will cancel to leave us with a 6. So 5 into 6 is equal to 30. On the left hand side expression, 2 and 4 are in the denominator, which will make the common denominator to be equal to an 8. 3.14 into 169 minus 8 into 30, which is equal to 240. This bit of the calculation is a wee bit time consuming. We'll do it. 3.14 into 169 will translate to a 530.66 minus 240 divided by 8. 530 minus 240 is equal to 290. 290.66 divided by 8, which will be equal to 36.33. So that's the area of the shaded region. Quickly summarize the last bit of the calculation in a printed form. Area is equal to half into pi into r square minus half into base into height. So this essentially translates to 3.14 into 169 by 4 into this 2, which makes it as 8. 8 is a common denominator. 3.14 into 169 minus 8 into 3240. The final answer is 36.33 square units. Concepts tested, two concepts. The first one, angle in a semicircle is a right angle. Unless you know this concept, you'll not be able to solve this question. The second one is knowing the formula to compute the area of a semicircle, which is half the area of a circle. So it is equal to pi r square divided by 2. And in all of these cases, watch out, you need to compute r. If diameter is given, take that step, write down the radius first, because there is quite a lot of time we'll end up using the diameter instead of the radius and make a mistake in this. Right?